Well, children, so there was some technical problem, sorry. So we're discussing that. You may be curious to know that why first of all refraction takes place, that is deviation of light takes place, not only in your refraction, even in case of your reflection also, okay. So there deviation of light was there. So for that I said yesterday that, so actually Fermat explained, okay, scientist by name Fermat, he explained why this deviation of light takes place. A very simple statement is that whenever the light tries to go from one to, it has to travel from one point to another point, it seeks, okay, it will go for a particular path along which it can take least time. So it is called as your least time principle also, okay, not least path, children, not least geometrical path. So what is the statement is, it will search a particular path, it will seek for a particular path along which it can take least time, children, okay. So concentrate, least time. So just to prove that, so what this is actually least time. Least time. Okay, so for that we are having one example. Even the similar one example is there even in your NCRT text also, but proof is not there. So if you follow differentiation, fine. Otherwise, mode of getting scared. Okay. So just for the curiosity, we are going to work it. So here we have selected two medium. So imagine this is your air medium is there. In which the speed of light I take it as suppose v1, or we can take it as even c also. Whereas let me take this as suppose water medium, and let me take speed of light as v2. Let the refract index of this medium be just mu I will take, because anyhow this is going to be what? 1. The refract index of air is how much? 1.0003, but we are going to neglect that and we approximate as 1 itself, children. Okay. So here what we have done is, we have selected 2 points. Here 2 points are there. So one is point A is there, one is point B is there. Okay. So we are having 2 points, children. So one point is in the air medium, one point is in the water medium. Okay. And now we are going to discuss about the traveling of the light from point A to point B. Imagine here one source is there, so it has to travel from A to B. Then there are number of ways to go, and when I say least time it has to take, the first thing comes to your mind is let it go in shortest path, so that time also will be okay shortest. That won't happen because speed of light changes. Okay. See, I have drawn one shortest path A to B. So question is why did not choose that path? And so one I have taken what we are going to discuss, taking a point of point O, and at that point if it is incident at some angle, it is deviating from its path, that is bending towards the normal one I have taken. Then, so one more I have taken is, so instead of bending like this, so this length is appearing more compared to this length. Then if the speed is less in the second medium, let it go till here where it can go faster, and then let it take shortest path. So that also will come to your mind. Okay. So there are number of ways like this you can think. But south of this we are going to discuss just one which will satisfy the Snell's law. So only we apply Snell's law. Okay. And according to, of course, least time principle only, Fermat's principle only, and we are going to prove that this path will take what? Least time compared to this as well as this. Okay. So let us go for the proof. For that I am going to remove other 2 paths. So this we are not discussing. We are going to prove directly that AOB path becomes what? Not the shortest path, shortest time path. Okay. Least time. Well, okay. So if I take a normal at this point of incidence. Okay, let NM be what? The normal at that point of incidence, children. Now, to prove that this path is taking the least time, first I have to calculate the total time taken. Let us assume that it is taking time T1. T1 in the first medium and it is taking time T2 in the second medium. Okay, then what I can write? The total time taken to travel from A to B point, A to B point, I can write as what? T1 plus T2. But you know how to express time in terms of the what? Speed and distance. So I can write the same time as what? I can write the same time as distance traveled by velocity or speed. So that is AO divided by V1 I can write. Let me write this as AO divided by V1. Similarly, this I can write as what? BO or OB divided by what? V2. Okay, in the second medium. So OB divided by speed V2. I can write like this. But AO and OB we are not having information. So for that sake what I have done is, if suppose the shortest distance, okay, straight distance. Now you don't think that then why don't it go in this way, that way? Okay, like okay, in case of reflection if you are working out. So you have to carry out reflection, you have to carry out refraction. In that you have to think of least time. So if I take this distance, okay, the perpendicular distance between your A and B, I suppose D if I take, and between A and M, okay, in the first medium. So this distance, if I take it as the X, then remaining distance becomes what? If I draw here for reference, okay. So this distance becomes how much? Let me call it as point C. So OC distance became how much? D minus X. Okay. Well, and I have taken from the interface I have taken the perpendicular distance of A. Okay. From the interface as A and of B I have taken as B. So using simply Pythagoras theorem, you can write your AO and OB, children. That much you know I write directly. AO is what I can write? Square root of x square plus this side is how much? A square. Okay, I can write this as square root of x square plus a square divided by, we are having is what? So x square plus a square divided by, we are having is v1. Okay, v fine. So that became your AO. Okay, what is AO is? So x square plus this height. This not this one. This is your this distance. Okay. So we are having is x square plus a square divided by what? Okay. Square root of x square plus a square. Okay. Whereas OB becomes what, children? So OB we are having it as OB. I can write as OC square plus BC square. But OC square is what? D minus x square and BC is what? B square and root of that. So write carefully. Once again work out if you are interested. So we are having as a D minus x square plus B square. Right? Divided by, don't forget, V. This became our what? Total time taken. But what the format principle says? It says that it will go along a path through which it can take least time. Through which it can take least time. Means we have to prove that this is taking least time. And if you want to prove that is taking least time, so ultimately just observe here. This perpendicular distance is not going to change. This perpendicular distance is not going to change. Now, depending on where it is incident, this x changes and according to x your AO changes. And according to x D minus x changes, okay? And according to that your OB changes, okay? So all that depends on what? Mainly x. So at what distance along this surface, at what distance the light is going to be incident. If I have taken a particular already position, so let us prove for that it is the minimum time taking path. So this became your angle of incidence, let me call it as I, and this becomes your angle of refraction R. Right? Well, now for proving anything, hope you remember already your derivatives and all is going on, mathematics class, you might have become okay, experts in that. If that is the thing, good. Otherwise, wait for them to conduct the things. So we have one of the condition, okay, in the differentiation to prove the things as maximum and minimum. Let me maximum or minimum for both. Our first derivative should be what? Should be equal to 0, okay. And with respect to what you are checking, with respect to that it should be 0. Now we are checking with respect to what? This time is going to be decided based on the what? How much x you are choosing, because your AO and OBs will depend on the what? X. Fine. Then what is the condition? For t to be minimum, t to be minimum, what should happen? dt by dx should become equal to what? 0. Okay. Remember children. Like this, you might have done even in the charge distribution, all those things. Okay. So dt by dx should be equal to 0, or even in case of the last year, okay, certain things, minima, maximas, when you work out wherever numericals, you can carry out this type of conditions. dt by dx becomes equal to what? 0. Now, let us differentiate this then. Anyway, LHS is what? Already 0, because it should be 0. So LHS we are having is already 0. Carry out the LHS. Differentiate. So if I differentiate, it becomes what? This is x square plus a square to the power of 1 by 2 is there. First it becomes 1 by 2 times, because we are having like d by dx of square root of x square plus, or you can write this, x square plus a square to the power of 1 by 2. How will you do? Power times this. Okay, so first it becomes is half times x square plus a square to the power of what? N minus 1 it should be. 1 by 2 minus 1. That becomes what? Minus 1 by 2. So since it becomes minus 1 by 2, I will take it to the denominator. Okay. So I will take it to the denominator. Hope you got it. X square plus a square. Again I am saying this derivation is not there for your syllabus, but this example and all they are given in your book, okay, in CRT for just reference. So not of getting scared, but once if you are used to your differentiation, you will feel these things as easier. But again this term is a function of x, hence I have to differentiate this also. This becomes what? 2 times x. We got as 2 times x, okay. But don't forget, by v1 is the x term. By v. Next, second term. So this also becomes 1 by 2 times, same with, so I write directly. So 1 by 2 times the square root of, same thing remains because it's also square root, d minus x whole square plus b square. Okay, but inside the root again you are having as a function of x. So this part becomes what? Like d minus x square should first differentiate. That becomes 2 times d minus x, and again x you are differentiate, okay, because d minus x also is a function of x again. So that becomes what? Minus 1 to 2 and into v2, okay, the denominator. Fine, everyone is clear. Now let me separate the terms. Before that, 2 will get cancelled. So what is left then? X divided by, we are having square root of x square plus a square into v1 becomes equal to, so I have separated the terms, d minus x divided by square root of d minus x whole square plus b square into v. So minus sign I have separated the terms. Now observe this. What is this term and what is this term? So as per the diagram, if you take the two right angled triangles here, that is AOM and BOC. If you take these two right angled triangles, apply your trigonometry. So what is your sine I is going to be, children? So sine of I becomes what? What is opposite side is here? That becomes x. So x divided by, you are having square root of hypotenuse, which is nothing but x square plus a square. Similarly, second term becomes what? D minus x divided by square root of d minus x square plus b square. So hence we are having on the LHS and RHS as what? Sine of I divided by V1 will be equal to sine of R divided by V2. Or I can write sine I by sine R will be equal to what? V1 by V2. V1 by V2. But what you have proved yesterday this as? This you have proved as refract index of V1 by V2 or sin R by sin R. What they were? Refract index of second medium with respect to first medium. Now we are having only second medium refract index as mu. Of that of first medium is what? 1. So that becomes mu. Means which is nothing but actually our Snell's law. Snell's law. Hope everyone is clear. We start with least time condition only. And we proved that this path takes what? Least time, because that is obeying your law. Okay. So it's clear then why we have to satisfy why the light takes such a path which will satisfy the what? Snell's law. Snell's law. So do remember, it will deviate. Why it will not go and deviate like this? Why it will not go like this? Okay. The reason is simple, because mainly at the outset we explain it as what? Because speed of light changes. Why the light deviates means because speed of light changes. So apart from that, you should know that it has to satisfy what? Snell's law, because main condition is light seeks such a path which will take least time for reaching from one point to another point in the medium. So I have given the idea. You can even try for the reflection part also. But in the reflection part, do remember whether I take least path or least time, one and the same. Because what's your velocity is or speed is distance by time taken. But in the same medium, speed being the same, what I can say? Distance is what? Directly proportional to time. So you can speak in terms of least path also. Just check the diagram, you get your answer. Okay. Well, hope all of you enjoyed that how a refraction of light takes place, or why the light deviates from its path when it travels from one medium to another medium. Okay. But do remember, this was explained by Fermat, whereas later practically it was that ratio of sine of angle of incidence to the sine of angle of refraction should remain constant for a given pair of medium, but it was proved later by Snell, hence it is practically experimentally. So it is known as what? Snell's law. Well, children, so yesterday we had discussed regarding refraction at the plane surface already. So I did not give regarding deviation yesterday. So let us go for the deviation of light today. Well, if the light is traveling from rarer to denser medium, rarer to denser medium, we know that light is going to what? Bend towards the what? Instead of traveling in the straight path, it is bending towards the norm. Okay, bending towards the norm. If the angle of incidence we are having it as I, angle of refraction we are having it as say R. Now, if you take the vertically opposite angle, okay, that is AOM and the COM. This becomes what? Vertically opposite angle. So we are having the vertically opposite angle as equal to what? I itself. Then how much the light got deviated, children? The light would have traveled like this. Now light got deviated by this much path. So this becomes your deviation in this case. And how we can write deviation? Straightforward, it is available here. I minus R. So we have it as I minus R. Now similarly, instead of traveling from the rarer to denser medium, if it travels from denser to rarer medium, then what happens? The light will go away from its path, okay? Away from the norm. The light would have continued like this. Now instead of this, what happens? It goes away from the norm. Like this. Okay. This becomes your actual direction. So if you take deviation here, children, deviation here. So this is your angle of incidence. Now this becomes your angle of what? Refraction. And how much light got deviated? Only this much, okay? So the vertically opposite angle you are having is here. This is your I. So what I have to get? Deviation is here. This is your deviation. So deviation became how much here? This becomes total R minus I. So we are having as R minus I. So deviation is the what? Difference of the I and R. So depends on whether it is traveling from rarer to denser or denser to rarer. If rarer to denser, I minus R, or simply can be normal. If it bends towards the normal, I minus R. If it goes away from the normal, R minus R. Okay, this is one thing what I wanted to discuss here. Now let me complete one more topic which you need to refer in between, that is optical path. Then I will come for our main syllabus or derivation is not, but numericals we need, that is normal shift and the lateral shift. Okay, well, before that we'll go for the optical path. So suppose if you are having one medium of this much thickness, and if I make the light ray to travel here, light ray to travel through this, what happens? You are going to see that the wavelength of light decreases as compared to what? As compared to the air or vacuum medium. So this is in some medium, say of refractive index, we are having it as mu. Let me take its thickness. Yes, this width, okay, or the length along which it is traveling. Let me take it as something x. X distance it has to travel. But the same x distance if the light has to travel in air or vacuum. Or let me take it as vacuum distance. Okay. If I take it as suppose vacuum, if I take vacuum, then what you are going to observe? The wavelength will be odd. Wavelength will be more compared to here. Okay. So let me call here wavelength as lambda in medium. So here we are going to find this in the same distance. If you take the wavelength will be what? Large. Okay. So distance traveled is same, but here it is traveling with what speed? It is traveling with speed c. Whereas here it is traveling with what speed? V. It is traveling with the speed. Now let us discuss. To travel through this same distance, okay, we are having same distance, we are setting the condition. Same distance to travel. If it is taking time here as say capital T and here it is taking time suppose small t. Let us write the absolute refract index of this medium. So ultimately that becomes what? With respect to air, let me write as mu m itself. Okay. So mu m means other side is what? Air or vacuum will be right. Understood? That is called as absolute refractive index. How will you write C divided by Vm? C divided by Vm because or V. Okay. V or Vm. It is traveling here with speed Vm in a medium. Here it is traveling with speed C in the vacuum or the air. Now, this further speed I can write as what? Distance by time taken, children. So here it becomes what? Distance is what? Same in both the case. Time taken here is sorry, small t. Whereas here distance is same. Time taken I have taken in a medium as capital. That became what? T by T. Or I can say that what? Capital T equal to we are having mu times the small t. So what this indicates? Clearly or indirectly it indicates that speed of light decreases when it travels from the vacuum to the what? Any other medium. Okay, including air, but we neglect that as refractive index is almost same. Just here, since it is going to be more than 1, suppose if you take class 1.5 is less, 1.5 times more time it is taking to travel, meaning is what? Speed is less. To come from the school to come from your home to college, say you are from the same colony and you are neighbors only. If one is taking more time along the same path compared to you, meaning is what? That another friend, your friend is coming what? So slowly his speed is what? Less. So obviously here what we are finding? The speed of light decreases when it enters the what? Any medium. So this, let us come to the optical path then, opposite. So we are going to keep here different conditions. So what I do now is, I am taking in the second case, so this is your first case. So what I am doing is, I will give the same time. I will give the same time for light to travel but in the what? In the vacuum, okay. So in the vacuum if I take, in the same time capital T, ultimately it is going to travel what? A very large distance, okay. So it travels some other distance. So instead of x, when it has traveled a distance x, so imagine this is going to travel, suppose both will start from here, it is going to travel some distance, say this much, okay. So it is traveling this much distance. Let me take this distance as the or delta. I'll take, usually we denote this by delta. Let me take it as a delta. So the same thing you can apply. So what will you write? Mu as equal to absolute refractive index of this medium. What will you write? Once again write as C by V of medium. V is the medium. But this time, your distances are not equal. Your distances are not equal. Instead, we are having times are equal. Okay. what it becomes then? In the same capital T time, it has traversed the distance of x. Okay, it becomes x by the what? This becomes, sorry, delta it is in the C, in the vacuum. Numerator is vacuum. Okay, it becomes a delta by what? In the same time capital. Whereas this has traversed only x distance, x divided by capital. Then what this indicates? Delta equal to, we are having is mu times the x. So what is x is? X is a geometrical length what we have taken in a medium. Okay, whereas light is traveling how much? Some excess distance it is traveling. That excess distance you can call as path difference, but only this is known as what? Optical path. This excess distance is known as optical path difference, whereas delta is known as what? Optical path. Delta is known as optical path. Okay, so what is optical path? It is the distance traveled by the light in the what? In the vacuum. In the vacuum in the same time as that of what? The light in a medium. And that how much you are going to get? It is going to be always mu times the distance traveled by the light in a medium. So how will you define that? Optical path is that distance which is going to be what? Mu times refractive index times of that given medium. The distance, geometrical distance, we call it geometrical length or geometrical distance traveled by the light in a given medium in the same time. Okay, that becomes your optical path. Okay, these all are just for the knowledge you should know. Let me come to two of the topics in the refraction observation itself. You are not having derivations for your syllabus, but you are having formulas given in your NCERT as well as, of course, numericals are there, expected linking as well as direct numericals, both in your theory as well as your MCQs. Well, so already we have seen the how refraction takes place, children. Now suppose if I take two parallel bounded medium, we can take it as suppose one glass medium, water medium, anything, but parallel bounded medium. Okay, so I am taking one glass medium here, glass slab we can call. So this is our glass slab. Say I can take it as A, B is one surface and CD is another surface. And if I make a light ray to incident on the interface AB, on the interface AB, so it has to traverse say a light ray is incident at this point, we know that it is going to bend, and here once again it is going to what? It is going to move away from the normal. Okay, move away from the normal. Let us start the normal here also. So if you take here, if I take this as angle of incidence, this as what? Angle of incidence, in the first air medium we can call, and this also we are having is once again what? Air medium itself, but this I have taken as glass medium. Okay, I have taken as glass medium. Let the refractive index of glass medium be mu we are taking, and this angle I take it as I. This becomes what? Angle R. But this angle also is what? Alternate angle we are having because normals are there, parallel to each other. This also I call it as R because both are alternate angles. Let me call this as angle of emergence E. Okay, we take it as angle of emergence E children. So let the ray incident be P, Q, R and S. This much is clear. Now let us apply this Snell's law at the interface AB and CD. What is interface? A surface separating two mediums. AB also is separating what? Air and glass. Again CD is separating what? Glass and air. So at the two interface. Okay. So apply Snell's law. So try to understand this because you need for solving your numericals, if not derivation. Okay, a clear understanding should be there. Applying Snell's law. First, I'm applying at the interface. At the interface, that is AB. Okay, let us apply at A. See, yesterday I did not tell you. Even you can write your law as what? N of so you are having when the light is entering from here to here, second medium is what? Glass. So what will you write? Mu of glass with respect to A. Okay, that becomes what? That becomes sine of I by sine of R. Okay, now this is nothing but we are having it as what? Mu of glass. Mu2 by mu1 children, mu of air. I can have a cross multiplication. So what I can write? The mu A into sine I, mu A into sine I equal to what I can write? Mu of glass into sine of R. Sine of R. Okay, or in general we can write as mu1 sine I equal to mu2 sine I. What these are? Easy to remember because mu1 is what? Where you are taking I. Okay, angle I. This medium itself. Mu t is what? Where you are taking angle of refraction R. That would be. You can remember however you feel comfortable. Let me write in a similar way. So what it becomes? Area of mu A is what? One is that if you want, you can write general also. Let me keep it mu of glass, mu of air as it is. So I'll write as mu of air into sine of I will be equal to what? Mu of glass into sine of R. I can write like this. Well, if you come to the second interface, here at CD when you apply, now this becomes first medium because light is incident here, okay, from the glass medium and emerging what? Getting refracted into the what once again? Deviating to the air medium. So this becomes as if your angle of incidence, this becomes as if your angle of refraction. So only sometimes you may get confused, so only I will this easy to write. Right? That medium, that angle. That medium, that angle. Okay. Hope you got it. What I can write here? This medium, that is mu g into sine of what? R. So at any interface you can apply like this. So try to remember like this, easy to write. So similarly, mu of A into sine of angle of emergency. Okay, you can write like this. Well, but observe these two equations, what you are having. Mu A sin I also is equal to what? Mu G sin I. And here also mu A sin A equal to what? Once again mu G sin I. Since these both are equal to what? Mu G sin I, hence these two should be what? Equal. So this implies mu A sin I will be equal to mu A sin E. Okay. So mu A got cancelled. Sin I equal to sin A. Both functions are same itself. Then I should be equal to what? E. So this implies angle I is equal to what? Angle of emergence. So do remember. But this you observe only if you are having what? If you are having parallel bounded medium. Parallel bounded medium. Okay, medium. Now let us take. Suppose in the absence of this glass slab, how the ray would have continued? The ray would have continued like this. The ray would have continued like this. Now, I am not showing error mark on this. The ray would have continued like this. Now, but the ray is what? Here. Then it got shifted laterally, sidewise. So, this is shift. How much it got shifted, children? So, this much it got shifted, okay? This much it got shifted, okay? This is shift, let me call it as T. This shift is known as what? That RT is known as lateral shift. So what is lateral shift? Whenever the light travels through a parallel bounded medium, the incident light will shift through a small distance parallel, and this perpendicular distance between the incident ray and the emergent ray. Emerging out into the same medium back, we call it as emergent ray. R is known as emergent ray. So the perpendicular distance between your incident ray and the emergent ray is not deviation. No deviation is there. How much deviation? Direction is same, is deviation is 0. So this perpendicular distance we call it as lateral shift. You can write as LS or SL. Okay, no problem. So this is known as what? Lateral shift. So what is we are going to work on then? We are working on the lateral shift. Okay. Let us use the notation as SL. So calculating SL is, this is SL. RT is what? RT here is nothing but our shift. Okay. So let us calculate the shift. So for calculating that, let me produce this normal. This right angle. And let us take thickness of this glass slab as T. Let us take what is T is thickness of the glass slab, children. Okay. Well, so let me take a refract index of this as mu g. So that is almost not required now geometry. So let us continue. So what I can write this one from this triangle. From this particular triangle, if you take this RT, LS, what I can write? Since it's a perpendicular distance, this is what? This is going to be where I am it as a right angle triangle. This total angle is what? Vertically opposite angle I. Hence only this much angle becomes what, children? I minus R. Observe carefully. Once again, redraw it bit bigger and try to understand. So in that triangle, if I take QRT, so I am writing here separately. In triangle, refer the triangle. QRT. QRT. What I can write sine of I minus R as? Sine of I minus R angle. What I can write? Opposite side. Opposite side itself is nothing but what? RT. That is SL. SL divided by what I can write? The QR. So first let me write the RT divided by RT by QR. Okay, RT by QR. Therefore, what I can write? RT is nothing but what? LS. So LS what I can write then? QR into sine of I minus R. Sine of I minus R. But QR we don't have any information. So instead of that, let us express in terms of thickness of the glass slab. So for that sake, I am referring QMR triangle. Okay, so if I take in triangle QMR, what you can write? Since this angle is R, your Q angle in the triangle is, that is MQR is what? Angle R is the So we can write it as, so once again, I can go for the cos angle. So what is cos of r, children? What is cos of r you are finding? Cos of r. Cos of r we are having is what? I can write as qm divided by the qr. So I can write as qm divided by qr. Therefore qr became what? Qr I can have it as qm is what? Qm itself is nothing but our thickness of the slab. Qm is nothing but thickness of the slab. I can write as T divided by cos r. Cos r. So our lateral shift equation. Lateral shift equation became what, children? Lateral shift will be equal to, only qr was missing, we got it. So T divided by cos r into sine of I minus r. So important, again I am saying, you don't have derivation for your syllabus, but equation we are going to use, okay? And you should know here, your I and R are what? Angle of incidence at the first interface and angle of refraction also at the first interface. So your lateral shift is not depending on what? Not depending on the glass slab or whatever the medium, you cannot say like that, okay? Because your angle of refraction depends on this. Seeing only the formula, don't decide that on what factors it depends, okay? It depends on what? Certainly it depends on the medium, parallel bonded medium as well as surrounding medium, because your deviation, how much it takes place, is decided by a medium, pair of medium, not just one medium, pair of medium. Already I told yesterday that if the light is entering at the same 60 degrees into the water, okay, then it may deviate, you may have the angle of refraction as 45 degrees, okay. But if it is entering from water to glass, it will be different, okay. So it differs from one medium to what? Another medium. Not only one medium to another medium, it depends on even pair of medium. What pair you are going to take, not just second medium. So even what pair you are taking, which is first medium, which is second medium, will decide what your the angle of refraction. Hence, it depends on the what? Thickness of that parallelly bounded medium, as well as it depends on the nature of pair of medium and angle of incidence and angle of refraction. Hope everyone is clear. Okay. So this is known as lateral shift. So again I am repeating, what is lateral shift? So whenever the light ray travels through the parallel bounded optical medium, then it is going to shift from its initial path, and the perpendicular distance between the incident ray and the emergent ray is known as what? Lateral shift. Okay. So have a glance, children. Well, so everyone is clear regarding the lateral shift and derivation. Let us go for the one more shift and interesting and maximum will get in your objective questions compared to theory. Well, so let us take one more situation. If you are having once again a pair of medium, and imagine that you are having a water trough. Okay, this is a water trough you are having, and this side you can think of the air medium, and this you are having it as, say again, I have taken as already water. So water is the, say of refraction index, let me take it as mu w. So this will called as mu of air. Okay. Now if I take any one source of light inside this water medium, so imagine that you are having actually water medium. So in this water medium, suppose if you are keeping a source of light here, okay, we are having a source of light. Let me call this as object. Okay, let me call this as object, and this object, if suppose from the interface xy, if it is at a depth of, if it is at a depth of, say suppose d is there. Okay, the source of light is at a depth of d is there. Now if I take from this a light ray incident normally at this interface, what happens? A ray incident normally, it has to go what? Undeviated. That's where exactly Snell's law fails. We define in terms of velocity as v1 by v2. Okay. So suppose if I take a ray here, it goes what? Undeviated. It goes undeviated. So this ray goes undeviated. This goes undeviated. So let me take this point as, suppose it goes along A. It goes undeviated along A. Let me take one more point here. But this point, remember, we are making some assumption. This point I am taking very close to point A. Just because you have to make out the diagram, I am drawing far. Okay, I am choosing one more point C. What is the C point on the interface? Actually, it is very close to the point A. Okay, the C point is actually very close to the point A. If the point is very close to A, then what happens? This angle becomes very small. If I have here, suppose the angle becomes what? Very small. Small means what? Less than 10 degrees. Where you can approximate your sine theta and tan theta as theta, or even sine theta you can take it as tan theta. Okay, good. Now suppose if I take the normal here, we know that light is traveling from where? From the denser medium to know air medium, rarer medium. Okay, it is traveling from denser to rarer, obviously. It goes what? It goes away from the norm. It goes away from the norm. Okay, it goes away from the norm. Let us go back to our things. Image formation. Okay, if someone is observing from here, that person feels somewhere else, and that where they feel, if someone is observing from here, Okay, if someone is observing from here, they feel somewhere else, where they feel, okay, so where they feel depends on what? Depends on the where the two rays will either meet or appears to diverge from. Already two rays we have taken, one is going this way, one is going this way. Both are not going to meet practically. So what we can do then? We'll produce back. Okay. So if I produce back, this ray appears to be what? As if coming from, this point. Even if I produce, this also meets here. So when I produce, these both rays are what? Meeting at this point. Then they feel as if this bulb is what? Here. Okay, the bulb is here, of course, of the same size will be there. So we are going to observe the image of that here. Means practically is it shifted? Because this normal shift, all of you will observe in your day-to-day life. In the schooling and all, they are given the example. When you keep a pen or something in a water glass, it appears to be bent. Or I'll give you one more experiment today. Just do it. Take a transparent glass. No, sorry, not transparent glass. Take your steel glasses, circular, but of small size. Take it like a tumbler, or you can take even cup. You can take. Okay. So put one 5 rupees or coin or any of one bead or something. Okay, any one object which colorful or easily you can recognize. Keep it at the bottom. Pour the water and don't pour the water at once. Just be side. Just hold the cup like this. Okay, but it should be like you cannot see it. Just go on slowly pouring the water. You can see that after some time you start visualizing that particular object, but not sitting anywhere. Just that angle has to suit like this exactly. Okay, how much shift takes place depends on what is the depth of the object from the interface, from the water surface. If you are pouring water, okay. So that depends on this depth of object. Accordingly, your angle of visualization should be there. You are going to visualize. Starting you are not seeing, but as you go on pouring the water, at certain level you visualize. Exactly on this idea you get your questions. What should be the height of the water so that the person can see from this angle, that angle? Some questions will come. Or what should be the radius of a disc to be covered on the surface so that fish inside the pond cannot see outside. All these things. Okay. But so those ideas will come on the total reflection as well as on your normal shift. Understand? So if you take here, so we are having this as what? So initially this is your angle of incidence, this is your angle of incidence, this is your angle of refraction. Being corresponding angle, I can take this as angle of refraction, this as angle of incidence. Let us take these two triangles, that is ACI and ACO triangle. Okay, in triangle ACI. In triangle ACI. What I can write? Sin R. Sin R can be taken as approximately as what? Tan R. Both angles are same because they will take afterwards what? Only R. Sin theta or tan theta taken as only theta. Doesn't matter okay, what theta you are taking. Okay. Well, because if angle is very small. So I being very small and R being very small, we are working with that approximation. So what you are going to write then? Tan R, what you can write? Opposite side by base. That becomes AC divided by AI. AC by AR. Okay. Similar in triangle. That is AOC. AOC. What you can write? Sine of IS. Again approximate as tan of I. Tan of 5. So is the AOC, the outside triangle. So again opposite side is what? AC. But base is what? AO. Okay. So AC by AC by U cloud. What happened? What we observed, children? When you are keeping any object inside a medium, if you are observing, this shift is what? This is not really shifted. The coin will not come up. The bottom of the water tank will not come up. Okay? Or your pen will not really bend. Okay? That is example for, of course, only refraction. Whereas here you are going to see it appears as if shifted. It appears as if shifted because of what? Because of refraction. When you observe along the normal, you feel as if it is shifted. Okay? You feel as if it is shifted. So this we call it as normal shift. Okay, what is normal shift? How will you define? Is it really shifting? No, it's not really shifting. So we take it as SN, normal shift. Okay. So what is the normal shift is? How much is the normal shift? This is the normal shift. Your OI is the what? Normal shift. Then how will you define systematically? The apparent shift, it appears like that. Anything which appears in the optics, we call it as apparent, not real. Okay? Real, we call it intrinsic. So, the apparent shift in the position of the object due to the due to the what? Due to the refraction when viewed along the normal. When viewed, because if you view from here, you cannot make out how much shifted. The shift is what? Along the normal. So when viewed along the normal is known as what? Normal shift. Again I am repeating. The apparent shift as per appearance. The apparent shift in the position of the object when due to refraction when viewed along the what? Normal is known as normal shift. So we have to calculate the normal shift. Before that, let us make one conclusion from these two. So what we are going to get then? Sin I by sin R, what you are getting? Sin I by sin R. This becomes what, children? If I divide these two, this by this. AC cancels. Then we are going to get is AI divided by AO. Okay, if I divide all this as 1 and 2. Okay, so 2 by 1. We are having this 2 by 1 because sin I by sin R. That becomes what? AI by AO. What is AI, children? AI is what? Is it real depth of the object? No, these terms you observe carefully. What is AI is? AI we call it as apparent depth. From the surface we measure depth of the object. As per appearance, object appears to be, bulb appears to be here. But really bulb is here. So it is as per appearance. It is known as apparent depth. Apparent depth. Whereas the AO is known as real depth. Real depth. And for this you are having short forms and the short forms are valid. Apparent depth you can write like this and real depth R dot. Okay. So these short forms are valid, you can use it. So what I can say then? Sin I by sin R we got as what? Apparent depth. Apparent depth divided by real depth. Real depth. Okay. But what is your sin I by sin R? What is sin I by sin R? Refractive index of second medium with respect to first medium. So refractive index of second medium with respect to first medium, because your first medium is now water, but not glass, water. Okay. What is your first medium is? It is water because light is traveling from here to here. So second medium with respect to first medium. Okay, well, that you got. So this will be equal to what we got? We got as the apparent depth divided by what? Real depth. Real depth. So real depth already we have taken as a D. Let me take this as something x. The apparent depth, let me take it as something x. I can write as the x by d then. This can be taken for our reference as x by d. So call this as equation number. Now we have to work out on the what? Normal shift. Simple. For physics is over, now only geometry we have to do. What is this? Along this, along the normal, what I can write the shift as? I can write as AO minus AI. I can write as AO minus AI. So I will write the normal shift, we write as AO minus AI. Okay, because OI is our shift. Okay, so if I subtract in this much, that gives me what? OI. Okay, SL is nothing but our OI is there in this case. This is a shift. This can be written as AO minus AI. Now here, let us try to express this in terms of this. So let's say what I do is, I take AO common. If I take AO common, what I can write? 1 minus AI divided by AO I can write. 1 minus AI by AO I can write. But what is AO children? AO is what? AO is nothing but real depth, which is D we have taken. That becomes what? D into 1 minus. What is apparent? AI is nothing but apparent depth and AO is nothing but here we are. AI by AO is nothing but what? Apparent depth by real depth, which is nothing but sin I by sin R, which is nothing but where I write as mu A by mu W. So I can write as mu A by mu W. Okay, or I can write finally as the normal shift equal to D1 minus 1 divided by refract index of second medium with respect to what? First medium. Because if I take it, it becomes what? First medium with respect to this became UW first medium. Okay, first medium with respect to what? Second. Clear everyone? Hope everyone is clear, children. So this is whatever. In this case, what happens? If I take the present case, since we are having A as 1, it becomes simply what? D into 1 minus 1 divided by mu of water. I take it as only mu because other medium is here. Whenever other medium is here, you can take only that medium in which you are having the fish or coin, whatever the example or bulb, whatever they are going to give each other. So this is to calculate your normal shift. Now, in the normal shift, as I said, you'll be getting the questions like question of the fish something, okay? For any fisherman, okay, where it appears to be, or for a bird flying above the ocean, okay, where the bird, okay, that fish appears to be, or for the fish, where the bird appears to be, okay, because here you have taken this formula you got. This formula is when the object is in the water. Object is in the denser medium and observer is what? Observer is in the rarer medium. What you got the case is what? Real versus children. This is when we have the object, when object is in the denser medium and observer is what? Observer is in rarer medium. In rarer medium, okay. I will give you a question now. Now take in opposite way. Take one object here. Same way you can work out the things. Observe carefully. Take one normal ray. Okay, let it go from air to water. Take one more ray incident like this. Let it bend and try to observe from the water. Produce both the rays back. Work out your geometry. So I will give you assignment. Tomorrow I will give you any answer. Different matter. So, or I'll give the equation also. Suppose if you are having the object in the rare medium, try and get it. Okay, I am giving that to the equation. Yes, sir. Normal shift is going to be what? We are having it as that height, whatever the actual height is, the height of the bird, and into we are having it as the n minus 1 or mu minus 1. You can take any notation. mu minus 1. Clear? And the mu in this case we get as here. This equation also is important children. So this also is important. So according to this, what we got the mu as? Mu we had got as means refractive index of that denser medium. We had got as what? A real depth by apparent depth. If I make okay the reverse of this. So mu of what we got as what? Real depth by apparent depth. This is one more important relation. Real depth by the apparent depth. But if observer is in the denser medium, object in the rarer medium will get that also opposite. Formula also changes as well as you are getting this also opposite. What will you get? Understood. Apparent depth by real depth. Okay, so this equation as well as this equation is important. Similarly, if object is the rarer medium, these also should be known. But please try to derive these two. I won't derive tomorrow once again, it will take my time. Just I am going to give it as an assignment. I have given the idea of ray diagram. Try it out. If you want, otherwise just the derivation I will post on the WhatsApp group children. Okay. Well. So this is normal shift. What you are saying, if object is a denser medium, it appears to be at less depth. In the same way, when you draw the ray diagram for the other case, you are going to observe that bird appears to be at more height than the actual height. Here, object fish appears to be at what? Less depth. But in case of the other case you are finding is bird appears to be at more height than the actual height. Okay, well, hope you enjoyed the class. So work out on your lateral shift and normal shift. So tomorrow we are going to cover the yesterday's and today's parts numerical completely. Then afterwards we'll go for the total internal reflection. Okay. So just once again go through your yesterday's all the relations as well as today's lateral shift and normal shift. Of course, when you take that formats principle and all, only for our knowledge. Thank you children. Thank you for joining. Good day.